Hello, everyone. I'm Andrew. And so we're going to go over today first what SQL is. You guys all know what it is, but I'm going to get some background here just in case. Pablo is going to give a nice demo of our SQL CLI. And then I'm going to go into a deep dive on how Beam SQL actually works. So who here has used SQL before? That's right, everyone. So SQL is pretty widely used, and that's why we want to support it in Beam. It's much easier than writing in Java or Python, and most people already know how to program in it, so you don't need to learn the Beam SDK. Really, SQL is pretty straightforward. It's a relational model. You have a select statement that's your projection. You might run some functions, run some operators. You have from, where, and having clauses that are filters, and you have group by, and that's your aggregation. We've added some more advanced bits. I think you probably saw Tyler's talk yesterday on some new operators we're adding for streaming SQL. But really, if you're building one of these, you can express it in SQL. And just why Beam SQL versus, say, some other SQL engine is we're wide to wide. It's really easy to scale up. No built-in storage, so Beam SQL doesn't have a native table store format. We're data source agnostic. You can use PubSub, BigQuery, GCS, S3, whatever. Anything that you can write a Beam IO for, you can use with Beam SQL. And it's really key characteristic is that it supports streaming operations. And the important part of that is where is your data in time? And so these are the tumble, session, hop operators, which you've probably heard about in previous talks. But you want to be able to window your data, and Beam SQL will help you do that. And so there's a whole bunch of people behind Beam SQL. It's been around for a while. This slide is 6 months out of date. You can go check the Git repository if you want to see who all has contributed recently. But really, in the end, we end up with a SQL CLI that lets you create pipelines entirely in SQL without doing anything more than writing a create external table operator, maybe set your runner, and then run some SQL. And out comes your data. So Pablo's going to demo that for you now.
Hey, guys. All right, it's good that you can hear me. I need both hands, so I'm going to use this microphone. All right, this does look pretty good. Nod your head if you can see. All right, cool. So this is the Beam SQL shell. You can, it looks like any normal SQL shell. You might have seen it with other engines that have it too. And what is really cool is that you can create tables that come from any data, well, lots of data sources. So we're going to create a table. External table. It's going to be a sequence generator, so a very basic event time. Very basic table that is of type sequence. So we have this very basic sequence generator in Beam that all it does is it generates numbers in a stream. So we can go select from our input sequence. We'll say let's look at the first 10 rows on this stream, and here they are, right? So we see basically integers coming from 0 and on a stream, and they'll have their timestamp, right? And so what's cool about this is that then you can go and do, for instance, some aggregations on the stream, right? So let's say that you want to select the number of events that happen in a certain window, right? So as you might have done in SQL, you do a count, and you use a tumbling window. Let's do a 2-second window, and we're going to select from this input sequence. Well, let's not do 10. Let's make it run kind of quickly. Whoop, miss the group by.
Live demo.
Live demo. All right, so we're selecting from here. And of course, we want to group by the window. Tumble event time, enter a 2-second window. All right, here we go. And so we make it run. Again, this is also a streaming query. And so we have to wait until it computes everything. We're doing 6 windows, so it's about 12 seconds. I only selected the event. Can you believe that? All right. All right. Interval 2 seconds, and then from input sequence, group by the tumble. All right. Let's do a smaller limit. All right, there you go. So it's this stream in particular is doing about 5 elements per second, and so this is the first window where we started running the pipeline. But there you go, right? We have 10 elements on the next window, and so we added this this basic data source so you can try basic streaming queries without having to connect to Kafka or PubSub or whatever. But what if you want to have something more complicated? So one thing is that the CLI is extensible. If you want to add your own source of data, you just need to extend this class. In this case, we have a generator of data that has this kind of schema: a name, a team, a score, and an event time. So we have players generating some scores. Our players are Mexican wrestlers, and here basically what it does is we have a sequence generator at the top over here. And then we just do a Pardue that generates some random data. All right then, and so we're going to create that table. External table. We're going to call it team scores. And so we have the name, varchar team, varchar score, event time, timestamp. And the type of this table is demo because it's we're doing it for this demo, and we can select from this table, right? From team scores, limit 5. All right, so there you go. We have some events coming into our stream. They have a timestamp. There's a score. Each one of these players has a team, and so we're basically just showing the stream, right? And we can do some cool aggregations on it. So let's say that we want to have a rolling leaderboard, right? So we want to see which team has the highest score over certain windows. So we're going to do, so we have our team, our tumble, which is event time, and then 2-second intervals, and then we're going to sum all of the scores. So we're summing the scores for a specific team and a specific window. Sorry that it's a little low, but anyway, from team scores, we're going to group. So we want to group by the team and by the tumble, by the window, right? So we do team, comma, tumble, event time, interval of 2 seconds. Ooh. All right, this is, so we need, all right, we're going to do just, what did I miss? Sum, missed a comma. And then, all right, we're going to do the team, the tumble, comma, and then, sum over the team, sum of the scores from team scores, group by the team, tumble, event time, interval of 2 seconds. All right, and then we're gonna select the, let's group by team, score, select team, sum scores, team tumble, column scores, not found, oh my God, you guys. All right, select team, sum of score, tumble start, event time, interval 2 seconds. All right, we have the sum score of the team from team scores. And then we're going to group by the team, the tumble. All right, here we go. And then limit 5, cross your fingers. Whew, it's running. Thank you. There you go. Okay. So you have the blue team. They did pretty well on the first window. Then on the second window, the red team came back and they scored higher. Cool. And so I just wanted to show you one more thing. You can have a table that comes from a text file, and your text file can be in S3, GCS, but it can also be local. So in this case, we're gonna suppose that the blue team and the red team have locations. So in this case, the red team is in Seoul, and the blue team is in Mexico City. So let's create that table. Create external table. What is it? Team metadata. And so we're gonna do the team varchar, the city varchar, the country varchar, type text, and we provide a location. So in this case, the location for this table is all right, team metadata.csv. All right, and we can select from that table. Team metadata. This is not a stream. This is just an unbounded data source. So you just select directly from it. And we'll just do one more thing. Let's say that you want to do a stream aggregation, stream enrichment. Sorry. So let's say that you just want to see the country, right? So you want to look at the metadata from the country and the score, and let's look at the timestamp also. Event time from team metadata m team scores s, and then we have to join the streams, right? So we have to go m.team equals s.team, and that's it. We don't need to group because this is just a stream enrichment. There's no windowing or anything. So we just select the first five elements, and there, right? So we added the country to the score, right? Cool. I think. Do we have time for the extra demo? All right, cool. So we'll do one more. Let's say that we want to do an aggregation on the stream and enrich the stream that comes out of that. Okay. So we had our leaderboard, right, where we had the teams, and so now we want to build a leaderboard for the countries. So what does this look like, right? All right. Select. We're going to select first we want the team. No, not the team. We want the country. Country, and we want the sum of scores s.score over a specific window, right? Tumble start s.event time. Right. Interval of 2 seconds. So again, 2 second windows from team meta m. Team scores s, and so we want to join the stream. So we have m.team equals s.team, and we want to group by the country and the tumbling window s.event time inter of 2. I'll get back to that, but. We do tumble on the group, and we're gonna at 6. Ooh, it's running. All right, and so there it is. So we're taking a stream. We're doing some aggregations on the stream. We get a stream out, and then we enrich that stream, right? And so we have a leaderboard of countries. Mexico and South Korea tied on the first window, but then things got interesting, and South Korea won. Oh well. All right. So that's my demo. Thanks.
Thanks for the demo. That was really brave. But what Pablo was showing you here is the power of being able to live run and debug your SQL queries. If you were trying to do this in Java, you might sit there and you type in your code, and then you run the compiler, and then 20 seconds later it would go, oh, syntax error, and maybe 2 minutes later you'd be running your pipeline and go up, schema mismatch. So there's some real power here in being able to quickly develop and debug your SQL queries in an interactive shell, and that's really why we built this. So now for the deep dive. I'm going to tell you about how Beam SQL works under the hood, which I'm sure you all wanted to hear about. It's really just Apache Calcite, though. That's our secret. Don't tell anyone. So Calcite, for us in Beam SQL, it provides parsing, validation, conversion to relational algebra, conversion to physical execution plan, and then we have some actual implementation of the execution in Beam. But it also does the JDBC driver that powered that shell. SQL line is the UI on that shell, so that came from Julian Hyde, who is also one of the main contributors to Calcite. Very few pieces of Beam SQL are actually specific to Beam. So here's a block diagram of Beam SQL when you embed it into your Java pipeline. So this is one of the two paths, which not the one that we demoed, but the one that you may have seen in quite a few other talks. If you have a pipeline and you want to add a transform that is just a SQL query, you'll use the SQL transform.query command. Beam will then wrap your query with Calcite, which will do the parse, the validate, and convert it to a physical plan, which will then get converted back into the transforms required in Beam, and then that'll get embedded into your pipeline. If you're doing through JDBC, actually, Beam isn't involved until quite late in the process. Calcite powers the JDBC driver. It does all the parsing, the validate, and only at the final stages of converting it to a physical plan does it create a pipeline and add your generated transforms, which are generated in basically the same way as the embedded Java version, into the pipeline and then execute it. So for SQL parsing, Calcite mostly handles this for us. One of the unique pieces in Beam SQL is the create external table syntax, which we've added to the Calcite parser. They provide hooks to extend it with engine-specific DDL syntax, and so that's like the location operator. There's also a couple other operators providing extra data for like external data sources that might require a more complex configuration than just a location. So when Calcite processes your SQL, what it spits out is a relational model. Calcite calls these rel nodes for various operations like filter, project, join. There's two special ones, which are table scan and table modify. And so it looks sort of like this. It's a tree diagram. These are all pretty much translatable directly into nodes in the Beam model, it turns out. In fact, table scan and table modify never go into the Calcite versions. We just send them immediately to the Beam versions, which are IO sources and sinks. But most of the operators they all become P transforms, and most of them become pretty directly mapped versions from Calcite. So the one thing we do is we combine a couple of them to make the graph easier to generate and have less work for us. So Calcite implements the conversion from the logical plan to the physical plan using its Volcano optimizer, which is a cost-based optimizer. So that decides what order maybe the joins go versus the projects and filters. We also merge project and filter operators into a calc operator. So in Beam itself, you'll find in our source code, there's a Beam calc a beam join, a beam aggregation, beam values. The beam calc operator is just do basic filters and transforms. The beam join turns into a join operation. They all basically do what they say they do. But really, they're just beam p transforms. So some of the more complicated ones here are beam calc. And that's really just implementing your SQL Pardue type operations in Beam. As of Beam 2.10, we have a code generation module that implements this. So when you go and write a SQL operator, it will turn into Java code. And this is all actually powered by Calcite. Again, back to the Beam SQL is just Calcite. Calcite has a built-in reference implementation for handling pure Java pipelines that are effectively in memory on a single node. Well, we've wrapped that in such a way that we generate Java code that is a Pardue that goes and reads out a row of and does whatever processing it needs to do on that in Java and then emits that row again. And so it looks sort of like this. If you write a select statement that maybe selects a couple columns, doesn't select them all, but runs a user-defined function of convert. This is sort of like the example from Tyler's previous talk about currency conversion. Maybe select some items. What it ends up with is a pretty optimized version of your SQL in Java. It's probably comparable to what you'd write if you went and decided to write this do fun in pure Java instead. Calcite under the hood provides quite a few optimizations for us. For example, if you're calling a SQL function with a constant passed into it and it determines that that's a deterministic function, it'll just run the function on your constant and actually pass into the compiler the output of the function, so you can skip static operations. The compiler further optimizes this code, but in the end, you end up with something that's pretty efficient. So if you're wondering, should I write something in Beam SQL or should I write it in pure Java? Well, it turns out that you probably should just write it in Beam SQL. The other two special operators we have are the IO source and the IO sinks. And so this is how we hook into Calcite and say, okay, the inputs into this are P collections and the outputs are P collections. Really, we're just plumbing these directly into Calcite through a pluggable interface that we've hooked up between Beam and Calcite's table schema. So right now we have wrappers for text.io, Kafka, BigQuery, PubSub, and there's a new one for a streaming demo generator that Pablo just merged. But this is a pluggable interface, so you can write wrappers for your own, and Pablo showed you the source code. They're pretty straightforward. You just have to implement something that takes your table and converts it into a P collection, or takes in a P collection and stores it out to your table. So the other piece that handles specifically for the SQL shell is a thing called a numeral converter. If you look in the code, you'll find that this is wrapping all of your JDBC operations. So at the end of actually trying to implement JDBC, Calcite has a reference implementation that expects a Java list of all your rows. It's not quite a Java list, but it's more or less a Java list. And so what we do is we have this operator that generates a pipeline, goes and runs that pipeline, collects back all the results, and returns those to Calcite, which then bubbles it up to your SQL shell. So you can use more SQL shells than the one we have here if you have any JDBC compatible shell works. But right now, it only works with the direct runner and doesn't stream results. If someone wants a nice starter project on Beam, you can enhance our numeral converter code to actually stream results back to a shell. That would be really cool. That's on our to-do list. For runners that aren't the direct runner, we only support the insert query, which wasn't demoed here, but you can go select something and then insert it into another table. If it doesn't terminate, you won't get really anything back. But if it's a batch sort of operation, we do actually plumb back the number of rows that were affected, and that'll show up on your SQL output. Your SQL shell output as affected 10 rows or something like that. And that works through metrics, so it works on every runner. Unbounded queries also work on every runner, so pretty straightforward. So what's next? We've got quite a bit of work still left to go. How many people here are actually using Beam SQL? Yeah, see, we have quite a bit of work left to go. I only saw 2 hands go up. And so the biggest things I think that are stopping people are probably more I/O connectors. If every data source worked in Beam SQL out of the box, everyone would be using it, right? The other concept we have is metastores, which we actually have our first one implemented just recently. It's, what's it called now? Google Cloud Data Catalog. But what these do is they let you reference external storage systems that have your schemas and your tables predefined. So when you start up that shell, if you have a bunch of pub subtopics and a bunch of BigQuery and maybe some files in GCS, you don't have to go and type create table every time. You can store them in an external database, maybe even have some graphical configuration tool. We've got an intern right now working on cost-based optimization. It's going to be pretty great when it comes, but right now we just pass a constant in to everything has 10 rows. And if you only have 10 rows everywhere, it doesn't do a super effective job at optimizing. We also need to build some push down. So for example, if you're selecting from an external database, right now we just always do a table scan. And maybe you have something like BigQuery or Postgres that you want to pull data out of, and we know that you're only going to select a certain subset of your data. So we can push the piece of that SQL down to the database and only pull out what we need instead of the whole table. There's also a couple more places we can improve our performance with code generation. There's some aggregates that are implemented in Java that might be improved if we generated code instead of having an interpreter implement those. And of course, the hardest part, this is probably what's actually keeping people using it after IOs, is how do you do windows, how do you do triggers? And part of our problem in solving this is what sort of use cases do people want to implement on top of SQL? So if you've got some great use cases for SQL that you just can't do because you can't get your data windowed or triggered right, feel free to reach out to me or send an email to the mailing list, file us a Jira. We'd love to get some feedback on what you want. The other thing that we hope to take advantage of, and this is now we're getting into like the 5-year roadmap. Everyone loves the portability framework. It's going to make cross-language work way better. In the short term, you're probably going to be able to run or embed SQL into like Python pipelines. So you can write SQL, stick it into your pipeline. It'll go out and call the Java code. And from the perspective of a Python Beam user, you're just writing SQL and embedding it in your Python pipelines. But what's really powerful is eventually we'll be able to plumb that metadata about your SQL query down into the runners themselves. So something like Flink can say, oh, hey, wait, this is SQL. I know how to do SQL. And instead of us passing Flink a bunch of Java code to implement SQL, we'll just pass the SQL through to Flink. And you get your native Flink SQL. And so once this happens, the question of, well, why should I run Beam SQL? I'm already using Flink SQL. Becomes, well, it just becomes Flink SQL under the hood. You get all of the I/O connectors of Beam, and you get the portability of Beam. So SQL is going to benefit from portability both up and down the stack. Last thing, I had to put the vendor plug in here. Pablo and I both work at Google. So one of the things we built on top of this Beam SQL shell is we've actually built a GUI in BigQuery. So if you use BigQuery, you can go in here, you can configure the UI to actually run your jobs on Dataflow, launch a job, and it just passes it to Beam SQL under the hood. You don't have to download anything, and you can run Beam SQL jobs entirely in the cloud in a UI without downloading any code, compiling any code, or running a CLI. So it's pretty cool. I hear a couple other vendors are looking into doing fun things like this. So hopefully soon everyone will be using Beam SQL, and I'll come back next year and you'll all raise your hands. So thank you for sitting through our talk. I'm Andrew. This is Pablo. We're going to take your questions now.
All right. Thank you, Andrew and Pablo, for this talk. I would like to give you a chance now to ask a few questions. We'll start here and then in the back.
Hey, thanks for the talk. It was really interesting. There was no mention about the link of schemas and SQL. Is there any link or any plans to link both works?
Sorry, I didn't quite catch your question. Schemas and SQL.
Is there a link between both in the implementation, or there are plans to link them? Like
so schemas, Beam schemas are actually, SQL is the reference implementation of them. So they were all initially implemented for the use case of SQL. They're all plumbed through SQL.
Okay. No, because that was not clear from the presentation, so I just wanted to say.
Yeah. So that is somewhat missing from these slides because they're a little bit more generic than SQL. But under the hood, Beam takes heavily advantage of SQL or of schemas. And actually, let's go back a couple. This get operator is actually from schemas, and row is just effectively a schema type that is represented as an array. So it's all schemas under the hood. If you pass a data type into Beam SQL that is schema enabled, it will just work. It'll get implicitly converted to this row type, which Beam SQL and Calcite understand. You don't have to do anything to your data beyond making it work with Beam schemas. And then, do we have an example of create table? Yeah, I think we do. If you are doing the pure, yeah, here we go. If you're doing the pure SQL CLI, when you do create external table, when you define like foo, bizzle, timestamp, and give them types, that's implicitly creating a Beam schema under the hood and associating that with your I/O. So if you're using like pub/sub in this example, it's implicitly attaching that schema to pub/sub, to your pub/sub topic, and populating all the necessary bits for you. So there's no need for you to do anything with schemas at all. They just are all connected under the hood.
Okay, thank you.
So congrats for the UI thing. It really enables the pen user just to quickly write SQL queries. For the data flow, is that in alpha, beta? Is that in production?
The data flow UI at the very end is very much in alpha right now.
Okay.
It does not. The biggest thing is it doesn't have the quick turnaround times that we'd like. It takes about 5 minutes to start up a pipeline.
Okay. Do you have a time frame for going at least in beta? Not in.
I don't know if I can talk about that.
Okay.
Sergey's talk is, I think, in 2 talks. It's the, what is it? Beam on Dataflow talk that's upstairs at 3:20. That would be the talk to ask that question at.
Really looking forward. Thanks.
All right, thank you. Any other questions?
Me again. I'm curious about this SQL idea of portability of moving SQL to the other SQL. Because, well, probably that would be easy for Flink because they share the same Calcite origins. But if we think about Spark, I'm not really sure if the syntax will be there. So do you plan to translate the syntax too?
Yeah, even for Flink, and like I said, this is like 5 years out. Even for Flink, we would need to do some translation. Both of them are based on Calcite, but there's little quirks that are slightly different. In our ideal world, we could actually just pass the Calcite primitives into Flink, but that's not something the API supports today. So we would probably have to, in the Flink runner on Beam, we'd have to write some code that goes in, parses that SQL tree back out to the SQL statements that generate it, and feed that into Flink. The other thing is the IOs would end up, your table names would end up getting renamed when they get mapped into Flink's table API. So we need to rewrite those fields in the SQL to be the names that we generated for passing tables in.
Okay, thank you.
I think there's another question in the back. Did you raise your hand? No? Okay.
Hi, I was wondering, is there a reasonable path to having the interactivity in a notebook, being Jupyter or Colab?
Yeah, we've looked into that a bit. I think our first step forward is to actually getting the JDBC driver to be interactive, which it isn't right now. And I pointed that out in the future work of, if anyone wants a nice starter project, it might not be as easy as a starter project. But once we have an interactive JDBC driver, there's a good number of notebooks that can take advantage of that interface and plug into it. And then we can probably build on top of that fairly easily to have something to hook into notebooks.
All right, thank you. Any other questions? We have time for one last question. No? Okay. Thank you, Andrew and Pablo, so much for this talk, and we will resume in 5 minutes. Thank you.
Thank you.